Density curve is a smooth curve that describes the overall pattern of a distribution. They're useful for avoiding having to estimate heights of bars and bends and counting dots and all that stuff. So the idea is you have a distribution and you've made a continuous line of a curve, and it's basically a probability distribution. So there's two requirements. The first thing is it always has to sit on a horizontal axis. That makes sense. All of our displays have horizontal axis. And the second thing is that the area under it is exactly 1. So when we calculate an area underneath it, we are looking for a probability of a specific outcome. So that's what a density curve is. It follows the shape of the distribution. It always sits on a horizontal axis and has an area of exactly 1 underneath. Now when you look at a density curve, you need to be able to identify the mean and the median. So let me remind you of a couple of definitions. The mean is the balance point. The median divides the area under the curve in half. They may or may not be the same location. It depends on the shape. Remember, if it's skewed, the mean chases the tail a little bit. So the median is closer to the peak, and the mean is closer to the tail. Same thing if it's right skewed. Mean is closer to the median is closer to the peak, and the mean goes towards the tail. And remember, if it's symmetric, it could be uniform, it could be normal, mound shape, unimodal. If it's symmetric though, the mean and the median fall in the same place. So it's important to know those values when you look at a density curve. So according to the CDC, the heights of 12-year-old males is approximately normally distributed with a mean of 149 and a standard deviation of 9 centimeters. Sketch this distribution, labeling mean and the points of 1, 2, and 3 standard deviations from the mean. So it tells me the shape. It's normally distributed. So I'm going to draw a normally distributed curve with a horizontal axis. I'm going to place tick marks along it. Here it is, horizontal axis. I know the center, the mean is 149. It told me that. And so it's to sketch it, labeling the mean and the points 1, 2, and 3 standard deviations from the mean. So here's the mean, 149. And standard deviation is 9. So I'm basically going to add 9 to get to 158, add 9 again, mark it, subtract 9 down the left. And when I've drawn my curve, so then I'm going to connect my lines to the curve, recognizing that the mean, the mu, is the center, and this is 1 sigma away, 2 sigma, 3 sigma, 1, 2, and 3. Now, there is a rule in statistics. It's called the 68, 95, 99.7 rule, also called the empirical rule, that tells us that 68% of the observations will fall within one standard deviation of the mean, 95% will fall within 2, and 99.7 will fall within 3 standard deviations. So let's visually look at this. It only applies to normal distributions. So here it is. Here's your distribution. Okay, mean's right in the center. If I go out 1 standard deviation below and above, then we expect to see 68% of our area or observations under the curve at those locations. 95% of the observations will be 2 standard deviations out, below and above. And then 99.7% of the observations will be 3 above and below. Okay, so that's what the empirical rule says. It only works for normal distributions, and you do need to know those 3, because there will be some problems here and there where you can only use this rule to find those probabilities or areas. There are other tricks in the book, but right now, this may be the only thing you have. So you just know that 68 is 1 standard deviation, 95 is 2 out, and 99.7 is 3 out. Okay, so using another example we used back in 2.1 about the percentage of 12-year-old boys over and their heights. Okay, it told us that the mean height of a 12-year-old boy is 149, and the standard deviation was 9. Okay, so I have my curve here. Here's my curve. I put 149 in the center and I added 9 each way, subtracted 9 down, and then right in the center is my mean. Now, so the question says, about what percentage of 12-year-old boys will be over 158 centimeters tall? Well, there's 158 right here. So over that means I'm going to the right. So I'm looking for this area over here. So how can I think about this? Well, if I know that this portion right in here is 68%, if I subtract it from the 100% of the whole curve, that leaves me this section over here and this section to the left, that they're mirror images. But I only need one of them, so I would divide by 2. So mathematically, I'm doing 100 minus 68 divided by 2 gives me 16. So about 16% of the boys are over 158 centimeters. About what percentage of 12-year-old boys are between 131 and 140? Okay, well, look at my picture. 131 and 140 are right here. It's this little sliver of the chart that I'm looking for. So multiple ways you can find that percentage. It's really the distance between 1 standard deviation and 2 standard deviations out. Now, we know that 2 standard deviations out is 95%, and 1 standard deviation out is 68. So if I subtract those, that leaves me an area of 27. But I only want half of that because the 27 is both of them. I only want one side of the curve, so I divide it by 2. That gives me 13.5%. So I would say about 13.5% of boys are between 131 and 140 centimeters. All right, suppose that a distribution of test scores is approximately normal, and the middle to 95% of scores are between 72 and 84. What are the mean and the standard deviation of this distribution? Okay, so I know middle 95% means it's 2 standard deviations out. So I'm going to label those locations. There's 72, there's 84. The mean, because it's normal, is right in the center of those. So to find the center, I'm just going to average the 2. So add them up, divide by 2, that gives me a center of 78. Now, I don't know enough yet to find standard deviation, but the same idea is true. This location right here between them is symmetric, it's like in the center. So I need to find that midpoint. So I take 72 plus 78 divided by 2, that gives me a 75. Then same thing on the right side of this, 78 plus 84, add them up, divide by 2, I get 81. So then I label my curve. Now I know what those values are, and I can see what did I add each time, and it should be the same amount. So you'll notice that I'm adding 3 each time. That means the standard deviation is 3. The next question says, can you calculate the percent of scores that are above 80? Well, 80 falls between 78 and 81. It's between the mean and 1 standard deviation out. We don't know, 80's in there somewhere, but we don't have a tool yet in our box to find that. So 80 falls between mean and 1 standard deviation. The empirical rule will not work because it only works for 1, 2, and 3 standard deviations exactly. So we don't have the tools just yet for 80, but we will in the coming unit.